So let's start. So good morning, everyone. Today we are going to explore two of Python's most powerful data analysis libraries, which are NumPy and Pandas. While many of you are familiar with this, but I'll give you a quick refresher today, whether you are completely new to this data field or having some experience before. So this will help you to understand these two libraries better. So before diving into this NumPys and Pandas, so if you see in the context of data science, so these NumPys and Pandas are very foundational libraries because they solve the most critical challenges. For example, NumPy, so it will give you a fast mathematical operations, essentially for statistical analysis and machine learning algorithms, while Pandas, so these excels at transforming your data into very clean, structured formats, which are ready for the analysis. So together, so these NumPys and Pandas, so they streamline the data cleaning, exploration, data manipulation, and preparing the tasks that typically consume more time, right? So now with the help of this, you can able to focus on extracting only meaningful insight. So these are the very dynamic geo of data science. So NumPy, so on a summary, NumPy is like having a super powered calculator with you that can handle huge amounts of numerical data and mathematical calculations. And Pandas, so it can help you to organize, clean, and analyze your data. So today's agenda is, so first we'll explore NumPy and see how it is useful, and then we'll dive into Pandas and see how it can help to handle this real world data, and later we're going to see about regular expressions. Okay, so yeah, these two are very important to start with before going to the machine learning, deep learning, natural language processing. So okay, now let's see what is NumPy first. So we know, so this is a Python library. NumPy is a Python library for calculations and data analysis. So it is basically this NumPy is highlighted by using various operations and ability to make mathematical operations on arrays and matrices very fastly. So whenever if you want to work with larger arrays and do some mathematical operations quickly, then NumPy is the best choice. Okay, first, so if you want to use this NumPy, then you need to install it. So basically, so NumPys and Pandas are automatically installed while you set up your Python and all. But if you want to install it, then you need to use this command pip to install this NumPy. Pip install NumPy. This command will install NumPy. It's running. Yeah. Next, if you want to use this, we need to import this. Import NumPy as NPy. NP. So this NP is an alias for NumPy. It's like giving a nickname for NumPy. So that makes easier for us to type next. Next, let's see.
This
Creating,
ins uh, this install is in the command prompt. This command pip install numpy.
yeah. So if you're working with notebook, Jupyter notebook, then you can use this command into the cell, or if you're using some terminal, you can directly give this command in the terminal. So whether it's a command line terminal or in the cell, the Jupyter notebook cells.
Sorry, I lost you. Can you repeat again? I'm sorry.
Yeah, sure. Yeah, sure. So this is Jupyter notebook. So if you want to give any command over here, you will give in the cell. So these are the cells in Jupyter Notebook. Or else, if you want to give this command in terminal, you can give it in the terminal also. So if you are using some command line terminal, command prompt or PowerShell, you can directly give this command. Or if you're working with Jupyter Notebook, you can give the command into the cell. I hope it is clear.
But I'm getting invalid syntax in command prompt.
So you need to install like Anaconda prompt at first. Do one thing. You can either use the Jupyter notebook or you can go to Google Colab and give it over there.
Okay.
So now let's see creating these arrays. So first we see create how to create a 1D array. So first, so in order to create an array, you need to use this keyword np.array, array, array. Okay. So this is how we'll create the array np.array of, and I'm giving some numbers over here 1, 2, 3, 4, 5, and these are 5 numbers in my array. So I executed this and I'm printing this. See this? This is my array 1, 2, 3, 4, 5. So now if I want to check what is the type of this array, so it is nd array, numpy.nd array, the type it. So you need to use your type of array name, type of array name. Okay. And if you want to see the shape, it is 5 comma. So that means, so we have 5 numbers in a single row. We call this as an one-dimensional array. So it is 5 comma. That means 1, 2, 3, 4, 5. 5 numbers in a single row, which we call it as an one-dimensional array. So, so this is in this way you will create the 1D array. So just you will use this technique np.array of and the numbers. Now let's see how to create this 2D array using NumPy. Okay, this 2D array, it is like a table. Think of it like a table. So if you want to create 2D array, then in the same way np.array and the numbers. But here observe the difference over here. So there are two square brackets over here because you are creating a 2D array. So I'm executing it and printing it. If you observe the difference between here and here, this is array 1 and this is array 2. So this is one-dimensional array and this is two-dimensional array. Let's see how we can conform that. If you see the shape, it is 1 comma 5. That means here the shape is 1 comma 5. That means one row and 5 columns. And if you want to create another one, let's say this np.array of, I'm giving one list of 1, 2, 3, 4, 5, another one with 6, 7, 8, 9, 10. So always remember you need to use two square brackets for creating a 2D array. And if you observe the shape, now it is 2 comma 5. I'm printing this array 3. If you say this, it is 2 comma 5. That means 2 rows and 5 columns. So the first row contains 1, 2, 3, 4, 5, and the second row contains 6, 7, 8, 9, 10. So this is how your 2D array looks like. And this is how your 1D array looks like. Just a one row. And here it is multiple rows, creating a 2D array. Now reshaping the array. So reshaping in the array, that means let's say first we have this array 4 equals to np.array of 6, 7, 8, 9. Let's say I have these 4 numbers. Then I'm using this dot reshape, array 4 dot reshape to 2 comma 2, and then I'm printing. Let's see what happens here. Direct syntax. Okay, now let's see what happens. So after printing, so my my single row of numbers 6, 7, 8, 9 is turned into 2 comma 2 matrices. 6, 7, 8, 9. So what happened here? So if we try to reshape this array to 2 comma 2, that means 2 cross 2 grid. That means 4 numbers. So then this 4 numbers is transformed into this way: 6, 7 in the first row, 8 comma 9 in the second one. So what's the dimension of this? What's the shape of this? It's a 2 comma 2 grid. Let's say if you want to reshape with this 4 comma 1, then this 4 represents the rows, 1 represents the column, right? Say this, these four numbers transformed into four different rows, 6, 7, 8, 9. Okay. So now I want to reshape these four numbers in 3 comma 3 grid. What it says, cannot reshape array of size 4 into shape 3 comma 3. Why this error? Because for 3 cross 3 grid we need 9 numbers, right? 3 into 3 9, but we have only 4 numbers here. That's why we are getting this error. So we need to make sure our numbers and our shape matches. So for 2 comma 2 cross 2, that is 4 numbers, that's fine. For 4 cross 1, that's fine, 4 numbers. But for 3 comma 3 it is 9, but we are having only 4 numbers. So if I increase the numbers, let's say I'll increase to 9 numbers, 12, 13, 14, 15. So 1, 2, 3, 4. Yeah. So now let's see this. Now let's say this, the reshape of 3 comma 3. Now we have 9 numbers. So here it is 3 comma 3, 3 rows and 3 columns. So 3 numbers, 6, 7, 8 in the first row, 9, 10, 11 in the second row, 12, 13, 14 in the third row. So this is how you will reshape this. Now adding more values to 2D array. So if you, let's say I have this array, 11, 12, 13, 14, 15, 16, 17. So 11 to 15, 16 to 20. So I'll print this array first. So this is a two-dimensional array containing 11, 12, 13, 14, 15 the first row and 16 to 20 the second. Now what I'll do here is I'll add 1 to the each number. Now if you observe the difference, before it is 7, now it is 12. Before it is 12 and now it is 13. What it is doing? So if I give the 1 over here, so this 1 is going and adding to the every element in this array. So it will access the every element and add +1 to it. So you can, the similar way you can perform any kind of calculation like addition, subtraction, multiplication. What it will do is it will go and do it for the every number in this array. So this is because this is simple calculation, but I just want you to explain. So how it is going to access the every element. So whether it will add add this number to this entire array or to the single element. Now, if you observe some inbuilt functions, so there are really very useful NumPy functions that help us to create arrays in different possible ways. First, we have np.arrange. So this np.arrange, so it's not arrange, it's arrange, it's arrange. So it is used to create some sequences. Say this, I'm giving np.arrange of 0, comma 10, comma 2. First, let's see what's the output. The output is 0, 2, 4, 6, 8. So let's understand now what is 0, 10, and 2. Here, 0 is the starting point and 10 is the stopping point. Here, 2 is the step size. So that's right. So 0 is my starting point, right? From my starting point to the ending point with the step size of 2, I'm getting the numbers 0, 2, 4, 6, 8. Okay. So it will exclude this number 10. Okay. So it's like counting 0, 2, 4, 6, 8, and it stops before reaching the 10. Okay. Now I'll give the simply np.arrange of 5, printing 5 numbers in a row, 0, 1, 2, 3, 4. So we know the indexing in array start with 0. That's why if I give the 5, I'm getting the numbers from 0 to 4. If you use this one, 2, comma 8, comma 3, another one. So we are getting the numbers from 2 to 8 with a difference of 3. So first our starting point is the 2 and our step size is 3. So 2 plus 3, 5. And if you further add 3 to this 5 and it will go to 8, right? But it will exclude this 8. So we'll get the numbers from 2 to 7 with a step size of 3. So I'm getting the output of 2 comma 5. Now the other function is ones function. So it will create arrays of ones. Ones function is used to create arrays of ones. So in order to create one function, so you need to use this keyword np.ones, ONES, ones of. So I'm giving 2 comma 3. Let's see what's the output. So there is 2 rows and 3 columns with ones. I need all my row values, column values with this ones. So my output is here, all ones. Now another function, identity matrix. So
Sorry to interrupt. One
creating I,
question.
yeah,
So in the previous function of once, right? Why the error
yeah,
is
ones.
the delimiter is with dot, there it is comma, right? Like, is there any difference between a comma and the dot?
No. So it is trying
It's
to
showing as one
giving the
dot.
float kind of numbers. Yeah.
Okay.
So it is just giving the float kind of numbers here.
Okay.
So now next, creating identity matrix. So what is identity matrix? So it's a 2D, it's an array with ones on the diagonals and zeros elsewhere. Let's see how it looks like. In order to create identity matrix, we will give EYE. So I'm giving the shape as 3 here. Now if you observe this, all the diagonal elements are ones and elsewhere it is 0. Remaining elements are zeros. So next we see some array attributes now. First, I'm giving the array, my two-dimensional array, 1, 2, 3, and 4, 5, 6. So this is my two-dimensional array. So so here are some attributes. First, I'm printing my array and then the shape of the array and then the dimensions, size of the array, data type. Let's see the output first. So first I have my array. My array is 1, 2, 3, and 4, 4, 6, 5. And the shape of the array is 2 comma 3. So it's 2 rows and 3 columns. And dimensions is a two-dimensional. And size of the array. So we have 6 elements here. 1, 2, 3, 4, 5, 6, 6 elements. And the data type it is int. So these are some of the useful attributes whenever you're working with data. So you say you have a data frame or if you have a larger arrays. So in order to get some information about your data first, so these are some useful attributes: shape and dimension, size and data type. So these are like kind of data analysis, very simple. Then we have NumPy operations. So this NumPy operation. So these are like basic arithmetics, so which are very super with using numbers. So let's say we have one array with the 1, 2, 3, 4, 5 elements, and second array from 10 to 50. So here I have my two arrays, array 1 and array 2. I'm performing some basic operations. So this is the plus operation. So this is the subtraction. This is the multiplication, and then yeah. See this now. Is the division. Okay, now.
Ganesh, why a data type it is showing int 32, like either integer or string something it show, right? Int 32.
So it's an integer or data type. So we can it contains all the numbers over here, right? So we did so it doesn't contain other data types, so string or nothing other
No,
ones.
no.
So we just have
My question
numbers,
is
right?
why 32, and I didn't understand.
In
Integer fine.
32, yeah, okay.
Yeah, integer fine. But 32, what
32
significant?
here, yeah. So this
Yeah.
32 means so it is using 32 bits of memory for every number here. So it is the bits of memory based on your operating system. So it will just display. The 32 basically means the bits of memory it is using. So simply you can take this as an int. Okay, so this 32 is just the memory.
Okay, it may varies, right?
Yes, yes.
Okay.
So it shows what kind of numbers it is showing. So it can be like into 32 or into 64. And for floats also it could be float 32, float 64. So if you take the whole numbers or the decimal numbers, then it could be into 64, into 64. That means it taking 64 bits of memory. And in 32 means 32 bits of memory. So now these are the NumPy operation. So what it is doing here, so it is adding up all the numbers 1 plus 10 and 2 plus 20, 3 plus 30, 4 plus 40, 5 plus 50. And here is the additional operation. And for subtraction, it is similar. So 1 minus 10, 2 minus 20, 3 minus 30. Okay. And same multiplication as well as the division. So it is dividing each number in a array 1 with the similar numbers, the same index number within the array 2. So 1 by 10, 2 by 20, 3 by 30, 4 by 40, and 5 by 50 for division. Now let's see some universal functions. So these universal functions are really helpful when you are performing some mathematical functions. So what what we understand from the above examples here, this numpys, this is for performing calculations for every number in your array, right? So similarly, if you use this universal functions also, it will perform calculation for every number in your array. Let's say I'm having my array with 10, 20, 30, 40, 50, my one dimensional array. Now I want to perform some mathematical functions like square root, exponential, logarithm, sine. Just I'll use this inbuilt methods, inbuilt functions, sqrt for square root, exp for exponent, dot log for log values, and dot sine for my sine values. If you observe this, so this is my result. So the square root of the numbers and square root of every number. So square root of 10, it will be 3.16. Square root of 20, 30. And exponent. So exponent of 10, 20, 30, 40. And then we have log values of for these numbers and sine values. So these functions makes your calculations easier. So without using formulas, so it will give you some inbuilt functions to calculate. Now moving to the array slicing and indexing. So now let's observe how to access different parts of your NumPy array. So first, let us create this two-dimensional array. So this is my two-dimensional array from, I have elements from 1 to 16. Now, so first I'm printing array of 0. So this is my array, ARR. So I'm giving in the square brackets, I'm giving the 0 here. What it is doing, what it is printing, this gets the very first row in your array. See this? So what's my first row in my array? 1, 2, 3, 4. So this is grabbing the first row in my array of 0. If I give the 1 over here, then it is bringing my second row. So we know like indexing in array starts with 0, right? So 0 means the first row, 1 means the second row. If I give the 2, then it is accessing the third row, 9, 10, 11, 12. Okay. So here I'm printing the final row over here, array of 3, 13, 14, 15, 16. Okay. Now, now let's say this array of 0 and 2. The output is 3. What it is giving, how we are getting this? So first array of 0. That means it will go through the first row, 1, 2, 3, 4. And then it takes the second number. Here it is 2, right? 2 means the third column. Again, it starts from 0. So 0 means the first column, 1, 5, 9, 13. And 1 is the second column, 2, 6, 10, 14. And 3, 7, 11, 15. So if I am giving the number here as 2, then it is going to this third column. Here this is the 0, and the second one is the second column is index number is 1, and third column index is 2. Okay, so then it is going to this third column and the first row. So first row, third column. So this is my first row, 1, 2, 3, 4, and the third column. What is this? Number 3. So I'm getting the output as 3. Array of 0 to output is 3. Let's see the another similar kind of example. 3, 3. That means last row, last column. Last row is 13, 14, 15, 16, and last column is 4, 8, 12, 16, right? This is my last column. So going to this last row and last column. So 16 is my output. 3, 3. So now, so this is some little trick here. So array of colon, comma, 1 colon, 2. So let's see the output first. So this is my output. So how we are getting this output? Now here we have comma here, right? So before comma and after comma. So before this comma, I have colon. That means I'm indicating all the rows. If I use the colon, then I'm indicating all the rows. Okay, go through all the rows and then comma. After comma, we are indicating so this data for columns. So for columns, I'm giving 1 is to 2, 1 colon 2. That means from index 1 to 2, but not including the 2, from index 1 to 2. So that's why we are getting we will get the second column here. That means index 1. So all the rows. So first go through all the rows and then index 1 to 2, but not including the 2. So index 1 means 2, 6, 10, 14. Okay. And then go to 2, but it will exclude the 2, right? So I'm getting only 2, 6, 10, 14. See this, my output is 2, 6, 10, 14, all the rows. And the index 1, the second row, second column, sorry. Okay. Let's see another similar example. 2 colon, 2 colon. So first, before comma, we have 2 colon. That means from row 2 to the end. So before comma, it represents the row, right? So for rows, I'm giving 2 column from row to the end, from row to end. And then for columns, 2 column again. That means from column 2 to the end. So we get a 2 cross 2 array here. So if you observe the array, so go from 2 to the end. So this is my second row. So that means second row means index. Okay, index of 3. So this is my second row, 11, 9, 10, 11, 12, 13, 14, 15, 16. And for columns, 2 column. That means from here, 3, 7, 11, 15, 4, 8, 12, 16. 2 to the end, right? So I'm getting 11, 12, 15, 16. Last 2 rows, last 2 columns. 11, 12, 15, 16. So this is my output. So if you observe this one now, 1 colon 3, comma 1 colon 3, it's the same kind of example. So 1 colon 3 means rows 1 and 2, but not 3. And again, 1 colon 3 means columns 1 and 2, but not 3. So this is my 1, 2, 3. 1, 2, 3, 4 is my first row. 5, 6, 7, 8 is my second row. 9, 10, 11, 12 is my third row. But it will exclude the 3, right? So my data is my row data is 1, 2, 3, 4, and 5, 6, 7, 8. So this is my row data. And for column, again 1, 2, 3. 1, 2, 3. Yeah. So this is my first row, like 2, 6, 10, 14, 3, 7, 11, 15. 4, 8, 12, 16, right? From here to here, 2 elements from 2 and 3, these columns. Okay. So for 1, 2, 3 rows, this is my first row, this is my second row. Okay. And first column, second column. So I'm getting 6, 7, 10, 11. See the 6, 7, 10, 11. It's just going to this numbers and accessing the data from this array. So yeah, you can directly, if you want to access some single element, so you can directly give in this way the row number, row index, and the column index. If you want to, if you want to get some multiple numbers, then you can use this operator column and before comma and after comma. Before comma, we will use for rows and after comma, we will use for indicating the columns. So this is a simpler way to access your array elements. And going to the array modification. So
The T
let's see like, yeah,
1:3 means it's a column and so row and column, right?
row and
Array,
column,
comma, column.
right? So before this comma, we are indicating
Row.
for rows. After comma,
Okay.
we are indicating for the columns.
Okay. Okay.
Yeah, now going for the array modification. So first, I'm creating my array, and this is my two-dimensional array, np.array of from 1 to 16. So this is my two-dimensional array. Now here, I'm giving array of 0, comma 0. So before we saw how to access this elements in the array, right? Now I'm accessing 0, comma 0, and I'm changing this 0, comma 0 to 100. So first 0, comma 0. This means first row, comma first column, right? So this is my first row, 1, 2, 3, 4, and 0, my first column, 1. So my output is 1. So go go to this array and access 0, comma 0 on this element 1 and change this value to 100. I'm just assigning new value to this 100. You see this? So it will go and access 0, comma 0. That means 1. And it will change the value from 1 to 100. So it's like going to the top left corner and value 1 gets replaced with 100. So now 3, comma 3. Okay. 3, comma 3 equals to 200. Okay. Go to the third column. Third row, third column, go and access that and change the number from the old value to the new value. My old value is 16, 3, comma 3. And I'm assigning the 16 with 200. So my output is 200 here. So the 16 gets changed to 200 now. So this is simply how you can access the element and change that numbers. So it's a simpler way. So
You
directly
give
go and you will
array
first
of
access this. Sorry.
if you give array of 0 equal to 100, then the entire row will be hundreds, right?
No. Array of 0 equals to 100.
Yeah. Instead of 0,
So
comma 0.
yes, yes. Say this. What you are getting?
Yeah, yeah. Entire row is hundreds. Yes. Okay,
Yes.
got it.
Okay. Now let's see the statistical functions. So these statistical functions are very useful. So when you analyzing the data, so whether if you have data frame or you have larger arrays, so using the statistical function, again, it will become very useful for you without writing some calculations, formulas, without using formulas, directly use these function names. We know these are some basic mathematical functions for this array without array. Okay. So this is my array, single dimension array, 10, 20, 30, 40. My first statistical function is mean. Mean means we know it's an average. So for average, just simply use dot mean, np dot mean of this array. Okay. So here we know for calculating average, so it will take all the numbers 10, 20, 30, 40, and it divided by how many numbers are there. So 10, 20, 30, 40. The addition is 100. So 100 divided by 4. 100 divided by 4 is 25. Okay. So this is our mean average. And similarly, we can find variance, standard deviation, median, some max number in the array, and min number in the array. So variance, we know how spread out the numbers are, right? First, it will find the mean, and then it see how far each number is from the mean, right? Variance. So our variance is 125. So it's a standard deviation. So 11.180 is the standard deviation. Median means we know it's a middle value. So 25 is the middle value from this entire array. And dot max use it to find the maximum number in the array. Dot min use it to find the minimum number in this array. So 40 is my largest number and 10 is my smallest number, minimum number. Okay, so these are some basic statistical functions. And then we have logical operators here. So first I'm taking the array of 10 to 19. I'm having the array numbers from 10 to 19. And in the print function, I'm giving array greater than 50. So what it is doing, first let's see the output. Okay, so this is my output. What it is doing here, first NumPy checks each number whether it is greater than 50 or not. So it will return true if it is yes, false if no. First 10, 10 greater than 50, no. So it's a false. 20, 20 greater than 50, no, it's a false statement. 30, it's a false statement. 40, it's a false. And 50, it's a false statement. Now 60, 60 is greater than 50. So here it is true. And 70, 80, 90, all these elements are greater than 50. So that's why my output is true here. So just simply it will return true if the statement is true. Else it will print the false. Okay. So these are some basic functions, I mean some operations for NumPys. We need to understand this well because when you're working with some larger arrays or when you're dealing with real world data, so these functions will help you to make your calculations very easier. So this is the power of NumPy. Without writing big calculations and formulas for against for statistics, for statistical functions, so you need to assign some formula, right? If you're using some general Python without using NumPy, so for mean calculation, you need to first add the number and divide the numbers. So instead of doing all those, we are using the simple inbuilt function. So, and for logical operators, for accessing the elements. Okay. So this makes our task very easier. So instead of focusing on analysis of data, you can directly, with the help of this NumPy, everything will makes you easier, right? Then concentrating on this thing, you can directly concentrate on training your models, getting the data, I mean, the context of data science. Okay. Now let's see what the pandas is about. Let's go quickly because we have regular expressions also. We need to see the regular expressions and pandas. Okay. So now pandas. So it is a very powerful library that makes working with data easy. Okay, as using your Excel, but with more capabilities. So this is a powerful data manipulation library, widely useful for data analysis and some cleaning tasks. So it will provide you, pandas will provide you two data structures, series and data frames. Okay. So again, it is a very, very important library because it has a lot of data manipulation capabilities, right? Okay. So we have two data types in pandas, series and data frame. First, series. Okay, what is series? So series is like one-dimensional array-like object that can hold any data type. It is like a single column in your table. Okay, let's say you have a table with rows and columns. Your single column, we can call it as a series. It's a one-dimensional array-like object that can hold any data type. So your column can hold any kind of data type, right? Similarly, the series. Okay, and then we have data frame. So data frame is a two-dimensional two-dimensional tabular data structure containing rows and columns. Okay, let's see how this series and data frames look like. First, for installing pandas, you will use this simple command, pip install pandas. In general, you don't want to install this NumPy and pandas because it automatically installed with Python. And now the series. So this is one of the two main data structures in pandas we have. First, it is series. So series is like a single column of the table, single column of a data. First, I'm importing my pandas. Okay. And first, let's say I have this list 1, 2, 3, 4, 5 list of elements 1, 2, 3, 4, 5. And then I'm using pd dot series of. Okay. I'm converting this list into series data frame. Okay. pd dot series of df. So df is my list. And then I'm printing this. Let's see how it looks like. Okay. See this. So observe the output 1, 2, 3, 4, 5, right? So if you observe this data, here each value has an index here. Each value 1, 2, 3, 4, 5 has an index here. The indexes are 0, 1, 2, 3, 4, 5. Okay. For this one element, 0 is the index. For this second, for the number 2, 1 is my index. So we are having values along with the indexes. Okay. So it is like giving each piece of data its own label. Okay, this is the label for this. So one is the label for this. So two is the label for this. Okay, so these are my labels and these are my values. Okay, so this is how your series data frame look like. Okay, so if you observe the type, then the data type here is panda dot core dot series. Okay, so it is telling us like, oh, yeah, this is the series data type. Now let's see different ways of creating this series. Let's say I'm having the dictionary df equals to a is my a, b, c are my keys, and 1, 2, 3 are my values. So this is my dictionary, and I'm converting this dictionary into series data frame. Again, I'm using this dot pd dot series of my data frame. So what is my dictionary here? df. Okay, I'm printing this. If you see the output now, printing my series of the data. Okay. Again, what are my values? 1, 2, 3. Now, now if you observe the labels, my key values A, B, C became as my labels here. Okay. So instead of numbers as indexes, we have letters. We have our key values. A, B, C as my index value, indexes. Okay. Labels. Okay. So this can't be only the numbers. This can be text also. Any kind of labels. Okay. Now, let's say instead of A, B, C, 0, 1, 2, 3, 4, 5, instead of these things, I want to give my label on my choice. I'm giving some custom index here. Okay. So let's say my list elements are 10, 20, 30, and I want to give my labels as apple, bananas, oranges. Let's say I have 10 apples, 20 bananas, and 30 oranges. So I want these names as my index names. So I'm taking another list called index and the names, and then I'm again using this pd dot series of df. So this is my list df comma index. What's my index? Index equals to the name, this one. Let's say like instead of index, I'll give labels. Okay, so my index now becomes labels. Okay, and now I'm printing my fruits data. So this, yeah, I'm having 10 apples, 20 bananas, and 30 oranges. So apple, bananas, oranges are my labels. 10, 20, 30 are my values. Okay. So this is how you give the custom index, and this is how you convert dictionary to a series and a list to a series. Okay, this is about series. So it is like a column of data, single column of data. Now let's understand about data frames. Okay, so first, let's say I have my data, I have my dictionary. Okay, in this dictionary, I have um, different keys and value pairs. So first I have names and John, Cox, Ren, list of names. I have list of names and list of ages, list of countries. So together I have a dictionary over here. Now I want to convert this dictionary to a data frame. What is data frame? So data frame is like you are having rows and columns, right? So now let's see how this name, age, country becomes rows and columns, and how this John Cox Ryan and this data becomes column data. I mean row data and name, age, country as a values, headers. So now I'm printing this. So I'm using pd dot data frame of and the dictionary. I'm passing data here to my data frame. Okay. Now my dictionary is converting to data frame here. So if you see this name, age, country, these three are my key values, right? This key becomes headers for my data frame. Okay. And the values inside these keys. So let's say for name, John, Cox, Ryan, it becomes values for the names and age 25, 30, 35 and country, India, US. Okay. For John, if you take single record John, so the name is John and his age is 25 and he belongs to India, and Cox, his age is 30 and he belongs to US. And Ryan, his age is 35 and he belongs to US. So see, this simple dictionary is converting into a data frame using this direct method, dot data framework. So if you have any time if you want to convert this dictionary to data frame, then you simply use this dot data framework. Okay. Now, now let's say this country, df of country. So this is my data frame, right? Name, age, country. Now, if I want to access single column in my data frame, here, here in this way, I would do df of country. So df is my data frame, right? In the square brackets, I'll give a country, the name of the column which I want to access. So I want to access country. So I'll give the country in a single quotes here. If you observe here this, my output is India, US, yes. I am accessing country values here, country column values. So India, US, US. Okay, if you want to access age column, then df of age. So 25, 30, 35. If you want to access name, then here are your names. So let's if I'm ignoring the single quotes. So without single quotes, if I give the name, then what it is giving? Name is not defined. Okay. So for strings, every time you need to use the single quotes. Df of name. Okay. This is how you will access the single column in your data frame. Now converting data frame into arrays.
One question.
Okay. Okay.
How can we make a distinct of US as a string as well as for 62 integer? Distinct, like output was India, US, US. But if you want to have India, US only.
Okay. So at that time, yeah, let's see that after this, after we have, yeah, for your question, let's see that after converting data frames into array, because there are some other functions which help us to find only the distinct values, only India, US. Okay. I, I'll tell you this little after. Okay.
Yeah, sure, go ahead.
Yeah. First, next we have converting data frame into array. Okay. Let's say first I'm importing NumPy as NP, and then I'm converting my data frame to array, np dot array of df. So I'm passing my df, my data frame, to array. Okay. Okay. Now, if you observe this output now, array of John 25 India, Cox, Ray, and data. Okay. Here, the data frame got converted to 2D array. Okay. First, we have data frame, and then with the help of this dot array, np dot array of, we converted this data frame to array. Here, each row of data frame became a row in the array. Okay, so each row in our data frame, John 25 India, became a row in my array, John 25 India. Okay, and then Cox 30 US, Ryan 35 US. Okay, so here now the index number 0, 1, 2 are gone, right? And notice the data type is object over here. Okay, instead of int float, here we have object here, another data type. So why we are getting this object here means we have mixed data types, right? Here 30 is the numerical value. John, Cox, Ray, and India, US are strings, right? So these names are strings and then ages are numbers, right? So, and again, countries are the strings. So it will treat this mixed data types as an object. Okay, whenever you see this data type as object, then it can be mixed data type. So if your array or data frame contains some mixed data types, then always it shows you an object. Okay. Next, creating a data frame from a list of dictionaries. Okay. First, let's say I have a list of dictionaries. If you observe this, these are square brackets. This is my list, indication of the list. And inside my list, I'm having another list of dictionaries. Okay. So I have name, age, country for John, and again for Cox, another record, and for Rayan, here is another record. Now I'm converting this list of dictionaries into a data frame. Let's see how my output looks like here. See, similarly, so how it happens before, the similarly here, the same. The name, age, country, it treated as the header names, column names, and the data, the values for the keys are represented as a data in your data frame. Okay. So this is how you will do, like converting a list to data frame, converting a dictionary to a data frame, okay, and converting your data frame into now arrays. Okay. Now let's understand how to read data from your files. So now first let's see. Let's say you're having some CSV file or Excel file, and if you want to look at its contents using pandas, then how to do it? Okay. So in pandas, in order to read data from your CSV file, you'll use this function, read CSV off. Okay. If you want to read data from Excel, then you will use read underscore Excel. If you observe this, we have read Excel, read CSV, and read HTML, read JSON, read PowerPoint, read pickle file. So based on our use case, if you want to read XML, then again read XML. If you want to read SQL table, SQL queries. So these are some functions to read the data from your files. Now let's say I'm having a CSV file naming like customers.csv. I'm having this file. So I want to read that file. So as it is a CSV file, so I'm using read underscore CSV. If it is an Excel file, I'll use read underscore Excel. Okay. So now I'm reading this file. Since df equals to pd dot read CSV of customers.csv. So this is, I'm already containing this. So I already have this file called customers.csv. Now I want to read customers.csv using pandas. Okay, using this read CSV, I'm printing the data. So this is my data now. Okay, this is my data which is contained in this customers.csv file. Okay, so I'm having data like customer ID, gender, age, annual income, spending score, and total I have 200 rows and 5 columns. Okay, these are my 5 columns. and I have 200 rows. So if I want to observe first
But
25
where,
records, yeah,
where we need to place the customer data CSV for reading?
you need to you can place it anywhere, but whenever you are reading this, make sure your file is contained your home path. Let's say if I give you the PWD here, so this is my present working directory. Right? So what's my present working directory? C users and my username. So I need to place the file into this path. Or if you are having your file in different path, you need to specify that path over here. Okay. But here I'm working with the same directory. So I just pasted my file inside this directory. That's why I'm reading it directly here. If your file is having in some different location, then you'll give the path here instead of your file name. Okay.
Thank you.
So let's say now, if I want to observe first 25 records in my data frame, then I'll use this function called head. So I'm executing this df.head of 25. So here we have 200 rows, right? So from the entire 200 rows, I need to fetch only the first 25 records. Okay. In order to fetch the first records, you need to use the dot head function. If you observe this, I'm having values from 1 to 25 and the index values from 0 to 24. Okay. So these are my first 25 records in my table. If I want to access last records in my table, then I'll use the function called tail. Okay. So dot tail of 25. Last 25 records in my table. So now instead of passing some value, I'll just leave it as empty dot head of. Okay. So if you don't pass any value by default, it will show you the first five rows. First five rows by default. In the same way, if I use the tail, then it will show the last five rows by default. Okay. If you pass some value, then it will display those values. So I'm passing here 10. So I'm getting the last 10 records. Head is for the first records, tail is for the last records. Okay. Now we have info. What this info does? Okay. When after using this dot info, I'm getting this some output, right? So I'm having data type and some having column information, data type information, right? So we have customer ID column names, a non-null count, some data types. So this is just displaying the information about my data frame. Okay, what are my columns? So what are the data types? How many non-null values are there? Okay, just fetching some information regarding my data frame.
Ganesh, I have a question. Like, if I want the data in between data, some of the data from after 100 to 150 or something
Mm.
like that.
Okay, so for that we will use dot loc and dot ilog. So we'll see that after. Okay, dot loc, dot log and ilog. Okay,
Okay.
I'll
Thank
show
you.
you that too. Okay. Okay, now again for accessing data frame. So we saw this before, right? So df of gender, if you want to access the gender column, then df is my data frame and gender. So this is my column name. Okay. And if I want to observe the type of the age column, okay, see this series. So I told you before, right? So every column is a series in your data frame. So that's why if you observe the type of this df, it is a series. Series is a column of data, single column of data. And if I want to print the entire data frame, here it is. So my df, my entire records are 200 rows into 5 columns. Here it won't display the 200 records. Okay. First, it will display first few records and the last few records. And now, yeah, like whenever you want to access some middle elements, let's say like from 100 to 150, or let's say from 70 to 80, how would you access middle elements in your data frame? Now let's see that accessing your data frame with some specified index numbers. Okay, now first, so here we have two different functions, dot lock and dot ilock to access elements with some specific index. Let's observe the differences between this. First, if I want to access row by label, then I'll use this lock function. Okay. First, let's see what's the output of this dot lock of 1. Okay. So what I'm giving here, 1 here to my lock function. That means it will go and access the first one, first label. Okay. So this is my label, right? 1. So I'm passing this label 1 to over here. So I'm getting the information which is related to the label 1. Okay. So for label 1, so we are having customer ID with the 2 and gender as male and age as 21, annual income 15 and 81. So I'm accessing this second row with the label 1. Okay. So for accessing this row by label, then you will use this function called lock. Let's see dot lock of 1, 2. Okay, what we are getting 21. Again here, first it will get value from the second row. Here 1 means second row, right? So it will get the value from the second row, and 2 means the third column. Okay, whenever here we are giving some values here, then we are indicating these are the indexes. Okay, the first it will go to the second row. So what is my second row? This is my second row, right? 2 male 21 15 81. So this is my second row, and then I'm specifying 2 here. That means third column. So this is my 0th column, this is my 1st column, this is my second one. So age is my column. So second row and the age column. Okay, this is my second row. And what's the age for the second row? 21, right? I'm getting a 21 is my output. Okay. And now if you observe some similar kind of example, dot lock 2 and 1, what it is displaying, it will get the value from 2, that means third row. 1 means second column. Okay, third row, second column. Let's see what's the value for third row and second column. So this is my third row, that means index 2, and my second column, that means index 1. So this is my second column with index 1. Okay, what's the value here? Female. So female is my output. Okay, now so this is about lock, how to use locks by label names. And now we have iLock. So what does this iLock does means? So again, if I use this dot iLock instead of lock, I'm using iLock. Okay, iLock of 1 and 1. That means here it gets the value from second row, second column. 1 means the second row. Again, 1 means the second column, right? So this is my second row and my second column. What's my second column? Male, right? This is my value, male. Okay. And if I want to, um, so if you want to access directly, so let's see first, I'm printing the output, what it is doing. It is giving some value as 21. Why it is giving 21? Because I'm using at function here. So what does at function do? So it is a direct access. You are giving the index numbers over here. So directly you are giving some index number here. Let's say I'm giving my second row of data. So go to second row of data and go to the age column. Okay. So what's the age for the second record? Okay, I'm asking it what's the age value for my second row. Okay, so this is my second row. What's the age in my second row? 21, right? This is printing 21. Directly you are accessing the contents using your specified indexes. Okay, so instead of giving the numbers, I can also give the column names here using this at function. So
Okay.
this is
One
generally
What
how
is
you will
the
access
difference
this.
between lock and iLock, Ganesh?
Yeah, I'm about to tell that one. Yeah. So lock is generally, it uses labels for index names. Okay. If you observe this, so these are zeros, ones, two, three, four. So these are your labels, right? Or we can also call this as index names. Okay. If you want to access elements with your labels or index names, then you want to use lock. Okay. So your index names or labels can be anything, right? It can't, it could be strings or it could be some names also, right? So in order to access your elements by labels or by index names, then you will use this function called lock. But if you want to use some integer positions, okay, for this record, the specified index is 0, right? For this index, your specified record index is 1, right? For the third row. Okay, for this, the specified index is 2. For this fourth row, the specified index is 3. So if you want to access elements with these index numbers, then you will use iLog. Okay. For for in the case of accessing elements with the label names, which is 0, 1, 2, 3, 4, then you want to use log. Okay. I hope the difference is clear now. Log and iLog.
Maybe can you elaborate again, please?
Yeah, sure. So for this data frame, so these are your labels, right? Or index names, right? 0, 1, 2,
Right.
3, 4, 195, 196 until 200. Okay. These we call as labels or index names. Okay. If you want to access your data with these label names, with these zeros here, 1. So let's see this log of 1 comma 2. Here 1 means it is going to this label. Okay. This label 1. Okay.
Right. Right.
For this label 1, what is the index position? 1 only. For this index label of 2, what is the index position? 2 only. For this label 3, what's the index position? 3. For this label 4, what's the index position? 4. For this 195, your index position is also 195. Okay. Here in this case, the labels and index names, index numbers, both are same in this example, right? So most of the cases, this is the scenario. Okay. So these we call as label names. If you want to access your data frame with these label names, then you will go and use log. So these label names can be 0 to 200, or you can change this label names to. So if you want to access a particular element with label names, you can use this. You can use log function. Okay. If you want to access with the index numbers, then you will use ilog for this zeroth label. So this is the first record, right? First row with the label 0, and also index position is also 0 over here. Okay, it won't be visible to us, but while we are calculating, so this is the first record. That means the index position is 0, and this is the second record. So the index position is 1. This is the third record, and here the index position is 2, right?
Okay.
So
Got it.
if
So
you
do
want
you
to
mean that
access,
log should be used to extract the complete row? iLog should be used to fetch one set of value, like one.
not like
It is something
complete
that
and
I.
one set of thing.
Mhm.
So accessing elements with the label names can be done using log function. Okay. So
Okay.
these are your labels, right? So for this particular record, you have label as well as you have index numbers, both,
Right.
right? So so labels can be shown here, right? 0, 1, 2, 3, 4, 5.
Yeah.
Okay.
Yeah. Yeah.
These labels can be shown here, right? So I'm directly passing my label number here. Okay, so here in this log function, my first value is 1 here. Okay, here 1 represents, it is not a index number, so it is a row, it's a label. Okay, my label of 1, so this is my label, right? 1. That means go into the second row with the label of 1. Okay, I'm
Right,
here
right,
passing 1 in the sense I'm passing my label here, label as 1 here,
right.
right? So in case of I log of 1, here I'm not passing the
Mhm.
label here, I'm passing the index number here. I'm referencing this one as index number here. So here for this record,
Okay,
index is 1 as well as label is also 1. Okay. Here I'm inferencing this one as an index number in ilog. I'm inferencing this one as a label in log. Okay.
okay. You mean to say earlier one of the scenario talking about label can be ABC, right? So if it is ABC, in iLock we should use it as A.
Right.
In case of
Exactly.
lock, it should be one. Obviously, it should be 1, 2, 3, 0, 1, 0, 2. Starts from 0.
Right.
Okay, okay. And okay, maybe do you mind talking about the alert? Some alert we are seeing, right? When is something I mean to know about.
Sorry, I didn't get the question.
There is one alert. I mean, kind of this, in red font we see some alert, right? Is something you
This
need to
one,
know? Yeah, yeah.
this is just a warning. You don't want to focus upon this one.
Okay.
Okay. So this is just a warning message. And we have another function called columns. So if you want to access all the column names in your data frame, then simply you'll use this function called dot columns of. So if I use this dot columns of, we will get all the column names: customer ID, gender, age, annual income, and spending score. Okay. So these are the column names. Now we will see how we manipulate our data frame. Okay. First, let's add a new column into our data frame. First,
We give
we
index,
have
we will
our
get the column name as well. I mean, particular column name, columns of 0 or 1, something like that. If we will give, we get a particular column name.
okay. Let's see that. Okay. You are telling like accessing like this, right? Columns of 0, 1, 2, 3, 4.
Yes, yes. Yeah.
Serious?
Yes. Okay.
Getting the
Thank
names,
you.
right? Yeah. So first, uh, let's say now we'll create a new column based on your old calculations. Okay. Let's first, I have my data frame right before. First, I'll print my data frame here. So this is my data frame. Now I want to add a column over here. Okay. So first I'm taking the salary column. What I will do here is I'll take the salary column, DF of salary, and then I'm taking this annual income. Okay, I think I already executed this. What I will do is, okay, okay. Now this is my data frame. So I'm having customer ID, gender, age, annual income, and spending score. I'm having 5 columns. Now I want to add a column called salary, where I need to add 10 to my annual income. So this is the example calculation. So I want to create a new column called salary. And then we are taking DF of annual income. So we are taking this annual income and then I'm adding 10 to it. Let's see how it looks like. So yeah, I have added a column now. So this is my old DF, old data frame. And now this is my new data frame containing it is containing the new column called salary. Okay. DF of salary. And what it is doing, it is taking the annual income and it is adding plus 10. So what is the annual income? 15, right? So for first record, DF of annual income 15 plus 10. So the value is 25. So the new salary column contains 25 for the first record. And again, for the second one, for the second record, 15 is my annual income and plus 10 gets 25. And third record, 16 plus 10 gets 26. Okay, here I'm creating a simple new column based on the old column. Okay, here each salary value is exactly 10 more than its corresponding annual income. Okay, so this calculation happens automatically for all the rows. You don't want to do for each and every record. It will do automatically for all the records in your data frame. Here again, you want to observe this thing. This new column is added to the right of the data frame. It is not in middle or at the start. Every time it will add at the right hand side of your data frame. Okay. And then if you want to remove a row, then you will use this command dot drop. Let's say, yeah, I created the salary column, right? Now, let's say I don't want the salary column. I want to remove this from my data frame. Then I'll use the command called drop. Df dot drop off. So what's my salary name? In the brackets, I'll specify the salary name and then I need to specify the axis here. Okay, here we have two different axes. So the row axis and column axis. So whenever you're giving axis equals to 1, that means you are representing the salary as a column. Okay, whenever if you specify the value here as 0, then it will go and fetch for the row called salary. Okay, if you specify axis equal to 0. But here I want to remove this column, right, called salary. Then I need to give the axis equals to 1. So df is my data frame dot drop of the column name salary in axis 1. Okay, that means in the columns. So I'm executing this, and if you say this, my salary column is deleted. So I can't say the salary column name before because we used this drop command, right? So it deleted. So the salary column is removed from our data frame. So this axis means we are telling our pandas axis equals to 1 means we are working with columns. Axis equal to 0 means we are working with rows. For example, I'll execute this once again. And now I added this column called salary once again. Now instead of 1, I'll specify a 0. Okay, it is executing and it is throwing me some error. What's the error? Salary not found in the axis. Okay, 0 means it is inferencing the rows. Okay, in rows we don't have column called salary, right? That's why it's throwing an error. So that's why I want to give the value as 1 because we need to remove this column called salary, right? As it is a column and it is specify the axis as 1. Okay, and now adding values to the column. Let's say I have my age column. Okay, age of 19, 21, 20, 23, 31. So if you want to add one record, I mean one value to your age, then simply you will access your column df of age, and then for age you are adding +1 to this. Df of age equals to df of age +1. So before we have 19, so I executed this multiple times, that's why it is 21. So before it is 21, now it is 23. Okay, before it is 20 and it is 22. I executed multiple times, that's why for again it added +1. Okay.
What is the benefit of adding a number into the column? What is the use case in real life?
Again, it depends on how you work it. For example, let's say you have a salary column. Um, so if you are working for a corporate company, if your manager given some hike, okay, go on. So this not hike, like let's say the festival bonus, okay, for this month salary, go and add 1,000 rupees for all the employees in your day, all the employees in the company as a festival bonus. Then what you will do? You will access the column and you will add 1,000 rupees as the festival bonus. Then your data frame will be updated, and based on that data you will generate the salaries, right?
Okay, got it. But if
Basically
we
it's
if we wanted to know what was the, 1 year back, what was the original salary, do we have any record for that also? We are,
yeah we
yeah.
yeah, okay. So
we-
for so it's again based on your use case. If you want to keep a new column separately, you can keep a new column separately. Because if you want to see the past data and the new data, if you want to observe the difference, then you will create new salary as the new column. Okay. If you want to just update the old column, you can do it.
Okay, thank you.
One question. We want to add distinct values for the one column. For suppose like for salary, for customer ID one, I have to add 50 rupees. I mean, sorry, 50, and for second, I have to add 100. Is it possible here?
For
You
that
understand my question?
scenario, yeah, I
Mhm.
understand your question. For this scenario, you need to access the column specifically and you need to add it. You can't add directly some different values to the different records. You need to access each and every record and add some value to it.
Okay. Okay.
Okay.
Okay.
Okay. Now we saw this drop comment, right? And if you want to drop multiple columns at a time, you can do that. Let's say I'm having this column. I'm keeping the salary column once again. Okay. And now I want to drop salary, annual income, both. Okay. How we can do achieve that? So in the drop function, in the same drop function, I'll take a list of columns. Okay. Salary, comma, annual income. Okay. So here I'm taking the list of columns. So I'm taking a list and inside the list, I'm placing the columns, whatever I need to delete. So I want to delete annual income and salary. So I'm placing salary, annual income, both in my list with axis 1. Okay. Now, if you observe this, we don't have columns called salary and annual income. We deleted both of it at a time. Okay. You can delete one column at a time or multiple at a time. Okay. Now I'll take the original DF once again. Okay.
If you want to delete particular data in a this data, like for suppose for the customer ID 200, I just want to delete only the salary only. I mean, entire data should be there, entire row should be there. Only the particular data like 200 or what is the salary is there, right? So only that
Hmm.
that value, salary
Okay.
value, I have to remove from the 200.
Okay. Then in this scenario, you need to use the same drop. Okay. Same drop. And instead of passing this column salary information, you need to pass the index over here. Okay. Instead of passing this thing, I'll pass the index. Let's say what's the index of salary 0, 1, 2, 3, 4, 5. If I use drop of 5, so this is what you are telling. Like if whenever I use the drop command and giving the index here, then the salary column is dropped here, entire salary column.
No, I'm not asking this one. Salary should be there. A particular row, salary has to be delete. The
Okay,
200 record. I mean, the customer ID 200. For that 200 customer ID, I want to remove the salary.
okay. So for some particular
Only that
record,
salary value. Yeah,
okay,
particular
only
record.
the salary, particular record.
Only.
Okay.
Yeah.
Then in this scenario, you would say like let's say like I am having this DF, right? So this DF4. So I am accessing the salary column first.
I hope to you have to add salary again. You already deleted.
Yeah, yes. So inside the DF, I'm taking this. If I want to access some particular record in my data frame, so in a column way, I need to inside the DF again. I need to use this column name in the DF. I want to access DF of salary. Okay, DF of salary. Let's say like uh, let's say I want to keep only records where I'm having salaries as 130. Displaying
No,
some error.
you didn't mention the function of drop.
Yeah,
You're just accessing here, right?
this is another way of accessing your element. So without using the drop command, okay. So if you want to access some
Okay.
specific elements in your data frame, so instead of dropping this salary column, okay. So if you want to without using drop, so I'm just showing you without using drop how you are accessing. So instead of this, I'm specifying. So what's the record I need to keep and what record I don't want to keep. So I'm just giving. So if I give this like this, okay. So first let's solve this error. So what it is saying unmatched of, okay. It is DF for salary, keyword salary. What is?
No, you dropped salary earlier, so run again. So
Oh, sorry. Yeah, I dropped the salary. Okay. If you see this DF of DF of salary not equals to 130. Here, what I'm doing here, I'm deleting a record where salary equals some specific value. Sorry, salary not equals to some specific value. Here, I'm taking only some particular records wherever salary is not equals to 130. Okay. So here, if you observe before I have 200 rows and 6 columns. Now I have 198 rows into 6 columns. I'm taking this specific information and I'm assigning this particular specific information to this DF. Okay. So directly instead of using drop, I'm specifying this information to this DF directly. Okay. I'm getting the updated information wherever the column value is 130. Okay. I'm just ignoring that 130. So here we have this record 130, right? 195 record. If you observe here in 195 record, here it is deleted. because we don't have the salary called 130. Okay, this is another way of accessing some specific elements and reassigning back to your data frame instead of directly using the drop command.
So it will delete entire row, right?
Yeah,
If
it will delete the
the
entire row.
salary equal to 130, that entire row will delete in this
Yes.
scenario.
Yeah, it will delete the entire row.
So it says the value is not equal to 130, right?
Yeah, not equals to 130. I mean, sorry, what are the values which are not equals to 130? It will take all the thing. So here it is 130, right? This record 195. So it will ignore this record 130.
Ignore in the sense delete.
No, no, no.
Yes,
Here what
it
it
won't
is
take. It won't
happening.
take the record.
No, it is again assigning to DF, excluding 130. Am I correct,
Yes, you are
Ganesh?
right. You are right.
Yeah. Okay.
So
No,
if
my
you
question is not this, Ganesh. Like, I want to remove only suppose I have a 195 column. In that 195 column, I have to remove only 130.
okay,
Okay. So
Entire row should be
okay.
there. Entire row should be there. I just want to remove only 130.
we
And
can
entire
assign null value to that.
Right.
You
Yeah,
can
so
assign
Ganesh,
null value or else you can use this at function. Okay. At of
and assign null
let's
value.
say, yeah, at of let's say this record 2, comma, salary equals to null. Okay. I'm assigning this second row salary column to null. Let's say like if you want to assign some specific value, yeah, it is to. So here, if I using null or nan, so it is saying null is not defined. I think I need to use this np dot
You can use null,
nan.
right? NON.
No, it's not non, it's nan. Nan. Okay, it's not non. So if I use this np dot nan, I'll use it will assign the null value. Here, what is name is not defined. NP is not defined. So I need to import NumPy over here. Import NumPy as NP. If you say this now, DF. Okay. Say this for this particular record. I'm changing and I'm not deleting this record now. I'm just changing this salary value to the null value. Okay.
got it. Thank you.
This is exactly what you need, right?
Yeah.
Hey Ganesh, can
So
you
I'm
please
just
send me the DF of DF? Had to drop. I just rejoined.
this one.
Yeah.
Okay. Okay. So here, what I'm doing here is I'm giving a condition here. Okay. DF of salary not equals to 130. So inside this DF, okay, what are the salary columns which are not equals to 130? Go and take these details inside this DF, okay, inside this DF, entire this total DF. I need to fetch some values with some specific condition, okay. So in the total records, go and fetch the salary column which are not equals to 130, okay, and after fetching, reassign it back to this DF, okay. So before I have 200 rows into 6 columns, right? Now, if you observe the DF, we are having 198 rows into 6 columns. Why? Because here it is ignoring the records which are having the salary record of 130, okay. Here, if you say this the 195th record, here the salary is 130, okay. Here it is not equals to 130, okay, but this is equals to 130. So that's why it will ignore the record. I want to take the records wherever the salary value is not equals to 130. I have 198 different records other than 130 as salary. Okay.
Okay, got it. Thanks.
So here, if you want to access some particular row, so particular row, so row 2 and with some particular column called salary, and I want to use some different number over here. So if I want to specify null value here, then I'll use np.nan. Okay. If I want to some specify other value here, then I'll specify other value here. What are value I require?
Okay, one clarification. So you have used the
Okay.
add function, right? So can we use lock and ilock as well, right?
Yes, you can use lock
Or
and ilock as well. You can access that particular element and reassign the new number.
okay.
So again, it depends on how you access lock or ilock or add function, or you can directly access the column
Yeah,
and
yeah,
find the
yeah.
specific value in the column. Yeah. And moving forward, we have value counts function. Okay. Let's say I'm having this gender column and I'm using this function called value count. So what it will do, it will count unique values in your column. So let's say in your gender column, what are the unique values? Okay. See this in the gender column, you have 110 unique female records and 88 male records. It is calculating count for unique values. Okay. So in gender, we have male and female, right? So we have 110 females and 88 males in your data frame. Okay, let's take another record. Let's say annual income. Okay. Here you have these many things. Okay. So annual income 54. 12 people are having the annual income of 54 and 12 people are having 78 and 6 people are having the annual income of 60. Okay. In this way, it will count the values for every record, every unique record. Okay. And let's see some more attributes. First, we have D type. So D types is used to find the data type of your columns. So your customer ID is an int and your gender is an object and age, annual income, spending score are your int. Salary is the floating number. Okay. And here the gender is only the object. So when it contains your column contains the mixed data type or the string data type, then your data type is object. If it contains integers, then int. If it contains float, then float, floating number, decimal numbers.
We are
Next
not
we have
any data type to salary, right? Like float or something. We introduce this column, salary column, annual income plus 10. So
right.
how it taken as a float 64? I mean, back end, how it
Because
taken?
say this. So we took the annual income and added 10, right? 15 plus 10. By default, instead of 20, 15 plus 10 is 25, right? So what we got 25.0 here. So instead of 25, it is given 25.0. By default, it is changing it to the floating numbers. Okay. It's the by
No,
default thing
how it
happening.
is taken like that?
Sorry.
How it is taken back end like I mean, it's like a
Like
only adding integer, right? Not 15 plus 10 is a 25. I mean, how it is converted to float?
so it is the
You
way they designed in the backend. Right? So if you don't want to convert it into float, you can also do it in the integer also. By
no,
default, this is
we
the thing
converted
happening here.
manually or what?
No, we haven't converted it manually. Automatically, after adding these things, so age plus 10, I mean, annual income plus 10, it is by default, it took the 15, it converted the 15 as 15.0 and it converted the 10 as 10.0 and it given the value as 25.0. Okay. So in backend, it is treating this number as a float. Okay. So this is just designed in a way the converting int into float by default. But if you don't like that, you can always change that to again change that back again to the integer.
Okay.
Okay. So if you don't like this column, df of salary, so now it is float right by default. So df of salary, I'm converting this to int using as type. Now if you say this, these floating numbers is converted to integers. So instead of 25.0, 2000.0, these are integer values, 25, 25, 2000, 26, 27. Okay. By default, it is float and you can convert to integer using this as type function. Okay. As type of int. Your floats can be converted to int. But your string values can't be converted to the numbers. Okay. So next we have describe attribute. If I run this describe, it shows me some statistical information, some statistical summary of your data. So we have customer ID, age, annual income, spending score, salary, right? So here are some statistical information, the count. So what's the count of customer ID column, the mean, standard deviation, what's the minimum record, 25% data, 50%, 75, max data, okay? These are some statistical information about each and every column. And then we have this info function. It gives us the general information about your table. And then we have columns. It displays the columns in your data frame. Okay. Now we have something called missing values. Okay. So these missing values, so if you want to check how many missing values in your data frame, then you can use this method, isNull dot sum of. So this for customer ID, gender, age, for all the columns, missing values are 0. So I have the perfect data. So all my 200 rows are containing some values. If in the case of some nan values or something, if some record is missing, it will display the count over here. For gender, if say like let's say like 10 records are missing, then the value here is 10. Okay. So it's just checking how many missing values in my entire data frame. If I don't give the sum over here, you will get the output is like this. So your data frame, and it is giving some Boolean value. Okay, false, 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 false. So that means here it is false. That means it is containing some value. If it is true, then it is a null value. Okay. If I use the sum of, then it will count the missing value for every column.
Okay, one
Next, if you want
clarification.
to,
When we
okay,
say is null, so would it
hmm,
consider only the empty values or blanks as well?
it will take your entire data frame and it will give some Boolean value for every record in
No,
your
no, no,
data
no. No,
frame.
I mean to say is null would consider only the empty values or blank values as well. If you say blank space as such, right? Would it consider that as well?
Yes, yes. It will treat
As
those
null?
also as a missing one.
Okay, okay.
So in general, when you load your data frame, so if it observes some blank value, it will keep the null values over there by default.
Okay, okay. Thank you.
Then we have, if you want to rename your column, let's say like I have the column called annual income. I just want to rename this annual income to only income. Then I need to use this function called rename, df dot rename of, and inside the bracket, I need to write like this, columns equals to, and in this curly braces, I need to mention my old column name. So annual income is my old column name, column. This is my new column name. This is how the syntax looks like. The rename of columns equals to this. Now, if you observe this, my annual income is changed to income. Okay. So if you want to, at a time, if you want to change names for multiple columns, then I'll just keep the comma here. And let's say like I'll take the age column and I'll change it to 6 column. Okay. Okay. Here again, my column is changed here. Okay. Sorry, this gender. I just want to replace the name for gender. Okay. So after keeping comma, you can add the new column details also. In this way, you will rename the columns. Dot rename function.
Can we do like this, like put it in all columns in a one list and uh, these values in, I mean, changing rename values in another list, like annual income, comma, gender, then
Mhm.
something like that we can do it. You
Yeah,
understand?
yeah, I understand your question.
Mm.
So in order to do like that, so you can always do it. So you can simply, you can take a list over here, okay, and then that list can be, and here you need to use the matching records, right? So after specifying your column names in your list, then you need to match those list elements with some specific new name, right? Okay, so you need to give two lists over here. First list is for the column names, and the second list for the new column names. Okay, first list contain the old column names, second list contain the new column names, and then here you need to use function called zip over here to match first record in the first list to the first record in your second list. Okay, here the command you need to use is zip command. Okay, zip. Inside the zip, you need to specify the to list over here. And then you need to use the rename. Okay, so going further, uh, yeah, we saw this before info. And if you want to change your data type of a column, you need to use this command called as type. So let's say we have income, so which is of data type int. If you want to convert this int data type to float, then you need to use this as type of float. Now, if you observe this income, before it is int, now it is converted to float. Okay. And next we have grouping the column. Okay, so I want to group by gender income. Let's see the output first. Okay, we converted this gender into not one dimensional. Okay.
I think there are two columns with the name sex. I
Yes,
think that
yes.
is the reason.
Right, right, yeah. So I'll execute this original DF once again. Now it is gender. Column not found income. Okay, it is annual income. It's annual income. What's this? Annual income.
There is a typo in the annual.
Yes, yes, yes. I'm just copying and pasting here. Okay. So I'm grouping by the gender and annual income. So first we grouped by gender. So it splits the data into males and females. First using group by gender, splits the records into males and females. And then for each group, we then calculate the mean of annual income. Okay. Mean of average income. So I'll take this annual income and dot mean of. It will count the mean of average income for this specific gender. Okay. First, it will group by gender. And after grouping by gender, it will take the annual income record and it calculate the mean for some specific for females and for males. This is how you will group the things by grouping the columns. So overall, uh, in NumPys and Pandas. So in NumPys, we created 1D and 2D arrays and performed some basic math operations, add, subtraction, multiplication. And then we performed some statistical functions, mean, max, minimum, max. And then we performed array indexing and slicing. And then we saw some different functions like np.arrange for creating sequences and np.ones for arrays of ones, np.I for identity matrix, and we have some mathematical operations like square root, exponential, logarithm using np.square root, np.exp, np.log. Okay, and going to the pandas. So these are different data structures in pandas, series and data frames. Okay, so series means one-dimensional data. So see a single column in your table, and data frame is a two-dimensional data containing rows and columns. And we saw how to read CSV files or Excel files using pd.read CSV or pd.read Excel. And then we access the data using LOC and lock and ilock. And then we added columns, we removed columns, we removed using drop command. Okay, and we added the columns based upon the old column, and we changed the data types using as type, and we handled some missing values using isNull function, and we grouped the things using group by aggregate function. Okay, mean. Okay, so this is in on the big picture. So NumPy is great for numerical calculations and array operations. Okay, and Pandas is perfect for data analysis and manipulation. So in general, if you have a data frame or if you have an Excel file, so if you want to do some analysis or some manipulation, then Pandas is the right choice. Or if you have a larger arrays or bigger numerical computations, then go for NumPy functions. Together, these forms the foundation for data analysis in the Python. Okay, in real world applications. So you will perform some data cleaning and preparation, and you will perform some statistical analysis, and you will perform some financial calculations, or you want to analyze some customer data or any different tasks. So which involves some structured data, then NumPy and Pandas is the best choice for analysis and manipulation. Okay.
Thank you for watching. Please like, share and subscribe to KKR Gen AI Innovations channel.